Hi, in this video I'm going to solve this exponential growth example, and it stands like this. Suppose a bacteria population starts with 10 bacteria and they divide every hour. Now, it says, assuming no bacteria die, what is the population 7 hours later? Now, when will there be 1 million bacteria? So I have here my super nice formula for exponential growth, which is a is equal to p times this base 1 plus r raised to t. And here is what everything stands for. A is for final value, p initial value, r for growth rate, and t stands for time. So let's see what we got here on our setting. We have 10 bacteria. It starts the population. So this is the initial value. So p it's equal to 10. And it says here they divide every hour. When saying divide in this case, they're saying they mean they double every hour. So the growth rate, if they double every hour, as you say, after 1 hour you have another bacteria. If you start with one bacteria, after 1 hour you will have now 2 bacteria. So that is to say that you have 100% of growth rate. So I'm going to write it as 100%, but remember, just we don't use a percent, so we have to divide this by 100. So if we have 100% and we divide it by 100, we convert it to a 1. So that's the growth rate. Now, the time in this case for the first question would be, what is the population of bacteria 7 hours later? So in this case, for the first question will be time equal to 7. So in this case, it's pretty simple example. So for A, we've got that the final amount will be equal to 10 raised to 1 plus 1, which is the growth rate. This one is the growth rate, raised to the time of 7. So in this case, A would be equal to 10 times 2 to the 7th power. So we can solve this out using our calculators. Will be A equal to, let's see, we got here 1,280 bacteria. That would be the population 7 hours later. This is bacteria. And that would be for the first question. Now let's get to the second one. When will there be 1,000 bacteria? So the second one is asking for time. So I'm going to use a different color. So this is I'm going to split this one. There it is. This was for the first question. Here we go. I'm going to write it over here. This is first question. Oh, this is there it is. This is the first question. Now for the second one, the initial population will still remain as 10 bacteria. The growth rate will remain the same as 1, but now we do not know the time. That's what actually we're being requested to find. But we do know the final value. In this case, the final value will be 1 million bacteria. So A would be 1 million bacteria. So let's see, let's put it on the formula. In this case, we have that it will be 1 million. There is 1 million. It's equal to 10. I'm going to simplify here. Well, it's going to be 1 plus 1 to the t power, which we do not know. We're trying to look for this t in this case. So we've got, I'm going to here first write this simplified as this. 1 million, it's equal to 10 times 2 to the 7, to the t power. So now I'm going to divide both sides by 10 to simplify this out. And we got that, simplify this 10, we got here. On the left, we'll get now 100,000. 100,000, it's equal to 2 to the t power. So I'm going to apply now a logarithm. I think I'm going to apply the log base 10, just because most of the people have it in the calculator. So the log base 10 of 100,000, it's equal to the log base 10 of 2 raised to the t power. Now I'm using here, we can solve out this one. Log base 10 of 100,000 is equal to 5 actually. And I'm going to use here this property to move the exponent down, multiplying over here. So we know that this log of 100,000 is equal to 5. So this would be 5, it's equal to t times the log of 2. Now the log of 2, we can divide both sides of this to simplify this out. I'm going to divide log base t both sides, log base 2, and we can simplify out here this log 2 as well. So we'll get to this. I'm going to continue over here. There it is. So we'll got that t, it's equal to 5 over the log of 10, log base 10 of 2. So we can solve this out, and a calculator would be, let me tell you exactly how much would it be. It's actually, the time would be equal to 16.6, which is, in other words, we require 16.6 hours to have 1 million bacteria given the starting conditions. So this would be all for the second question. And with this we are basically done with this video.